Hey everybody, welcome back to another YouTube tutorial. Today we'll be taking a look at part 3 of the tutorial AI car series. Today we'll be kind of getting our AI car ready for some advanced stuff. So this episode won't actually add a lot, sadly. It will make the walls invisible and will make them fully drive-through, kind of like there wasn't even walls. The walls will only be used to guide the AI and tell them how to brake. But we're going to shoot out multiple ray cars today, which we're not going to do much with yet. But in the next part, we're going to do quite a lot with it. And in the next few parts after that, we're going to do a lot with that. So without further ado, let's get into the video. Now, before we go edit the car AI blueprint, we should make a new blueprint. So right click on your content browser, go to blueprint class, then we'll make a new actor. We'll call this line trace collision. The reason we're calling this line trace collision is this will actually be the fin that the AI's line traces will use to brake. So we're going to go to this line trace collision. We're going to go to add. We'll go create a new box collision. And we'll just compile and save that, but we're not done with it yet. We should go to our vehicle advanced example map, go to edit, go to project settings, and then we should go to collision under engine, and we should create a new object channel. The reason I have an object channel here is because I tested a bit. You shouldn't have one. So just create a new object channel. Go here to name. This will be line trace collision, and then the default response should be overlap, and you can just sign. It told me duplicate name found because I created one, but yours should still be fine. Now that you're done there, you should go to your line trace collision, go to the box, and then scroll all the way down to collision, and then the collision presets will change the overlap all dynamic to custom. And then we'll use the object type world static or world dynamic and change it to line trace collision. You can compile and save that, but we're also going to add a cube. This will be the visualizer for the block. Now the problem is the cube is a bit bigger than the collision box. So we can fix that by going to the cube, setting its scale to 0.64. The 0.64 on all axes. And you can compile and save that. Now this will be the new thing we use instead of these walls. The reason we're changing up these walls is this allows the walls to be invisible in game. Oh yeah, very important. Go to the cube. And you should go to rendering and hidden in game. So the player can't see the cube. Now this is the thing we're going to be using as the new walls. It's fully drivable through, like there's no collision with it. And this means that the AI car can still brake, but they can go out of the track. So this line trace collision we're going to take. And just like you used to plop the walls around your track, you should do that with this. A handy tip for that is here above. You can see there's an angle by 10 degrees. You can change that down to 5. That means you can make it snap to only 5 degrees of freedom, which is pretty good. Really helps with the level design. I'm going to skip this part because you already know how to do this. We did it in the first part of the tutorial series, in fact. Now that we're done with that, we're going to go to our AI car blueprint. And then we should go to our line tracer function. When we're in our line tracer function, we're actually going to rewrite a bit of this code because we wrote this code to work with only the AI car and the track, but we want to support multiple cars, and this line trace by channel will not code for that. So we're going to rewrite a bit of the code. The line tracer, you're going to take that and then use an for loop. Important to use a for loop and not a for each loop. They're two different things. And this first index should be 0, last index should be 6, and that's a good start. Just move that out a bit. Now we should take our for loop and take this index and take this, promote to a local variable. The way I like to name local variables is I'd like to name them definite storing. So in this case, it would be current index. But I also like to use brackets to exclaim that this is a local variable. We'll plug this into the loop body. So at each loop, it will save the index to the current index. I will also take this for loops and this index, and also at the loop body, we'll make a select node. Now, the reason we're making a select node is we're going to rotate the view of our line traces so that we can detect all around the car. So now that we saved our current index, we can take that, get, and plug that into the index. And the return value of this will be used for vector rotate vector around axis. And this angle degree will be the return value in this. And the forward vector is the in vector, which will then be plugged into the multiplication. And here's the fin. We're going to require 7 pins, option 0 to 6, which is 7. And we're going to rotate them based on where they are. So for option 0, we're going to rotate it minus 90, so we'll go fully left. Option 1, minus 45. And then for option 5, we want to take that 45 and 90. So we have line traces on the left and right side of the car. We're not going to do anything with them yet, but it's good to already account for that in the future. Now, this get world location will change up a bit as well, but first we have to go to our viewport. We're going to add 2 more scene components. That's because I don't actually know a great way to write this code, and this is what I found to be the easiest. So we're going to add a new scene component, line trace. Could call this line trace left front offset, and then also we could just move that to the mesh, and then you could just Control W to duplicate that, and then we'll just call that right front. So right front, just remove the 1. And this line trace front left, we're going to move a bit to the left. Somewhere around the tires is good, so minus 40. And 1 plus 40. The reason why we're shooting out multiple front rear cars is I found that when the car is shooting only 1, sometimes it could misjudge a car in front of it and just ignore him and just go full speed into him, which is not what we really want. Now this line tracer, now we'll use another select node. And this, of course, will use our current index local again. So let's just get our local variables, current index. Plug that into the index. And then the return value will be based on the get world location here. We'll use different based for what line trace we want. Now let's take our upper select node and make, of course, 7 options. Option 0 to 6, which is 7. And then this get world location, we'll just copy that. And this location will be used for a majority of these, but for certain cases it will not be used. So we want to use it for option 0, 1, 3, 5, and 6. Option 2 and option 4 is the left and right offset line traces we made. So that means we can take this get world location, sorry, make another one. Plug in the line trace left front offset here. Plug in the line trace right front offset here. Then you can make option 2, the left one. And the line trace right front offset, the right one. And this will actually also be used for multiple stuff. So we'll just plug this into the get world location. This will be the one that's used for the math calculation here. And that will also be the one used for the start here. Then for now we can just plug the execution pin in. Now before we go on, it's important to note this rotate vector around axis. You actually need to take the Z, change it to 1, so it rotates on the Z axis. I kind of forgot about that. And this line trace by channel, oh, this is gonna be a fun one. We're going to have to delete all 3 of these front line trace hit result and trace hit question mark. We're going to have to make a multi-line trace and this is where the fun part comes in. We're not going to use channel anymore. We're going to use multi-line trace for objects. The reason is we want to know what object we're hitting before we use the information from the line trace. So this current index will take and plug the execution pin in. The start, of course, will be the select node at top here. And then this plus, of course, will be the end. You don't have to worry about this line trace start point. Every one of these will have a front vector the same way, that faces the same way. So you don't have to use another select node for that. That's perfectly fine. The reason we're using multi-line trace for objects is because we want to use these object types. And this is why we made an object type for that wall we created. So this object type we'll take and we'll make array. And these are all the objects the line trace will detect. We want to make it detect vehicles. And then we want to make it detect the line trace collision. So it will only detect those and won't use other things as information. The reason we're using the multi-line trace is we want to detect cars and walls at the same time later on. And the problem is with this is these out hits, they will actually be stored in an array because it's storing multiple hits in one. So it means we can't use this singular front line trace hit result anymore. We're going to have to make multiple arrays. And this is the fun part. We're going to have to cut a bit later in the video. But I'll pause it, of course, to make you copy a bit of code that's really important. So this out hit will take this out hit and promote to the local variable. This local variable will be the out or the current out hit result, and of course brackets local. And you also want to take this return value, promote it to a local variable. Yeah, move that up a bit. I like it that way, but you can of course make it the way you like. Plug in the execution pin, take this new local variable, like that, and name this the current return value. Of course, brackets again, local, really cleans up the code. And now this is where the fun part comes in. Going to make a switch node. The switch node will be based on integer, so switch on int is what we want. It's important you switch on that. Then we'll plug that in, and based on the integer, our current index, we're going to run different code. So let's add pin 0, 1, of course up to 6, and we're going to store each hit that we make here into its own separate variable. You might describe this as a bit wasteful, and I kinda agree with that, but this is just going to have to do for now. I think this is the best way to handle it. If any other UB5 pros are watching this video, please explain to me how you would do something like this. Now the switch on int will take 0. 0 is the complete left, so that means we'll take the 0, and then we'll create a new variable. We won't call this locals, we'll use actual variables that are global. And then this will be our left line trace hit result. This boolean will have to be switched for a hit result. And you have to click this little button to change it from a single to an array, which then we'll just set that on 0. And of course, to set that, we'll take our current out hit result and plug that up. And then we'll also make a new one called left line trace hit question mark. And this will be a boolean again, but this will not be an array. It will only be a single value. And then we'll set that with our current return value. Now, we're going to have to do this for each and every one of the possible line traces we're going to make. So I'll skip this video, and then when I've skipped this video, you should pause the video and just copy the variables I made. I made them the same way I made these at the top. That will just make my life and your life way easier. So let's skip this part. You can, of course, just pause the video, and when you're done here, you should have something like this. You might have noticed you might have compiled your code and there will be an error. That's because we have to replace a bit of the code in the event graph, and we'll do that now. But we'll also clean up these variables because they're taking up way too much space in the variable tab. The way we're going to do that is by taking our frontline trace hit result, and we'll change the category to hit results. You just click it and rename it. Now you'll see it create a new category. Drag all your hit results in here. This could take a bit of time, but it's way faster than typing out all that variables you just paused the video for. You can then just collapse that, because we're not going to do much with that except having them there. And you'll also want to take this, any of these booleans, and take the category, name it hit question mark. Now you can just drag all the hit question mark booleans in there. That will just make our code way cleaner. Also, we want to go here to our completed, and we'll just make a return node. And then we'll compile, save. There should be an error, but we'll go and fix that by going to our event graph. Now let's start by fixing this reference. You can get to that reference by just clicking on the error you're having. It'll take you there. And this frontline trace hit result distance doesn't work anymore because this variable isn't a fin anymore. So we have to delete that and take our hit result, our frontline trace hit result, get that, and then we'll use a get, a copy to the first index in the hit result, and then we'll also split the struct pin. Now it's gonna look quite ugly. I'm really sorry for that. So there's the getter. We'll take the distance and plug that into the map range clamp. Also noticed I made the mistake here. The in range B should actually be 1500, and the out range B should be 1. but there's a big chance you liked how aggressive that was. So if you want something that worked pretty similar to that, you can just skip this math range clamp. At least you can just skip that and just put the break at 1.0. I'm not going to do that for now. I liked how this worked. And you can compile, save, and you should see we don't have that error anymore. So let's start by editing this code to use the line traces we created. Like I said, we're only going to make the front line traces work for now. We'll use the sides later on the future parts of this tutorial series. Now that you've done this, we should go over to our front line trace hit, ? And this automatically, of course, throttles, but we are going to change this up a bit. So move this code away. And this front line trace hit, we're not only going to take in the front line trace hit, we're also gonna take in the multiple of the front line trace hits. So the condition should be taking in the front line trace hit, of course an OR, and then you should take in your hit result ? We should get our left front offset. That will be one of the hits that also works. I will also use another one for the right front offset. So if it doesn't detect any hits, it's safe to assume it's in a straight and it can just throttle away how it wants to, of course. But if it did detect something in front, we're going to have to change up this get corner. We're not just gonna get break. We want to take other cars in account. So let's start by doing that as well. Now we'll just go to our get corner function here in the event graph. And when we're not in the corner, we don't want to just break anymore. We want to take other cars into consideration. And the way we're going to do this is by using multiple cars, so much that we will in fact macro it. So we'll create a new macro called, it should be called cast to vehicle. Yeah, inputs and outputs. Drag the outputs out a bit. Gonna add a bit of code. Now we're gonna cast to AI car. So you might have noticed this, if we just cast to an AI car, that means this will only support AI cars. And yes, that's true. We'll help the support players later on in the series by moving everything to a component, which will make our lives way easier. In fact, well, that's for later parts of this tutorial series. Now take this object reference, just create, go to our inputs rather, plus, and we'll create a new hit result array. You should call this the hit result. This will be the one that's casted to. That will use a get, a copy, yeah. And then we'll split the struct pin and take this hit actor. I'll plug that into the object reference. And now we can just plug in all the execution pins. And yeah, that's all the references. We'll just fix that to be a vehicle. And you can also cast successful, yeah. And that's perfect. Now you can compile and save that. Now you can go back to your event graph. And this not in corner will cast to vehicle. Will cast to multiple vehicles. In fact, well, not multiple vehicles. We'll use multiple line traces. That's why we macro this. So copy, paste, copy, paste. We'll do this 3 times. So if the cast failed, it will cast to vehicle again. If the cast failed, it will cast to vehicle again. But we'll use different line traces. So let's start by using our left front offset. And just plugging that in. And then we'll use our front line trace hit result. And then we'll use our right front line trace, oh yeah, no, wrong one, offset. Plug that in. And boom. Now if all these 3 casts fails, that means we're going to use this break-in function we wrote. So if the cast fails, yep, the boom. It's no point into continuing to this. So we can just move that down below because we're gonna add all the code up. Just split up these up a bit. And yeah, this is already going pretty well. So sorry guys that I have to leave you alone for now. This video is getting quite long. So in the next video I'll be coding more of this function, these cars, and actually make the car react more to other cars around them. But for now this is just a good starting point, and your car should work the same way it did previously. So you can compile, save, and if you test it, you'll see it will play. And he works the same like he did. It hasn't really changed much. That's because, of course, we're coding the beginnings of something really big. So, before I go, I've actually forgotten something. This line trace collision. You should actually take this cube and take this can character step on, no, and collision presets. It blocks all dynamic. It has to have no collision. Because I found that it's actually still a wall that can crash into itself. And that's it. So if you see, we go again, you'll see, yeah, the car brakes like it normally does. And then it just follows the same way that nothing much changed. That's something we'll fix in the next part. So thanks for watching guys. If you like the content, please subscribe. It really helps me out with the algorithm. Hit like if you liked the video, hit dislike. And thanks for watching. Good night.